Alright, so nested switch statements. You can use uh, you can use switch as a part of statement sequence of an outer switch. This is called a nested switch. Since the switch statement defines as its own block, no conflicts can arise between the case constants in the inner switch and those in the outer switch. Right. So we can have the same constants within the inner switch and the outer switch. Okay. So here case 1 statement in the inner switch does not conflict with the case 1 statement in the outer switch. The count variable is compared only with the list of cases at the outer level. If count is 1, then the target is compared with the inner list cases. In summary, there are three features of switch statements to note. The switch differs from the if in that switch can only test for equality, whereas if can evaluate any Boolean expression. Okay, right. That is, switch can only look for a match between the values of the expression and one in the cases. No two case constants in the same switch can have identical value. Okay. Of course, a switch statement and an enclosing outer switch can have case constants in common. Okay. A switch statement is usually more efficient than a set of nested ifs. The last point is particularly interesting because it gives insight into how the Java compiler works. When it compiles the switch statements, the Java compiler will inspect each of the case constants and create a jump table that it will use for selecting the path of execution depending on the value of the expression. Therefore, if you need to select among a large group of values, switch statement will run much faster than the equivalent logic coded using a sequence of if-else. The compiler can do this because it knows that the case constants are all same type and simply must be compared for equality with the switch expression. The compiler has no such knowledge of a long list of if expressions. Okay, so this is important. Iteration statements. Java's iteration statements are for, while, and do while. These statements create what we commonly called loops. As you probably know, a loop repeatedly executes the same set of instructions until a termination condition is met. As you will see, Java has a loop to fit any programming need. Okay. While the while loop is Java's most fundamental loop statement. It repeats a statement or block while its controlling expression is okay. The while loop is Java's most fundamental loop statement. It repeats a statement or block while its controlling expression is true. Right. While condition, then body of loop. The condition can be any Boolean expression. The body of the loop will be executed as long as the condition expression is true. Okay, and when the condition becomes false, the control passes to the next line of code immediately following the loop. And the curly braces are necessary if only a single curly braces are unnecessary if only a single statement is being repeated. Here's a while loop that counts down from 10, printing exactly 10 lines of tick. Okay. You have, since the while loop evaluates its conditional expression at the top of the loop, the body of the loop will not execute even once if the condition is false to begin with. Okay. False to begin with. Right. The body of the while or any other Java's loop can be empty. This is because a null statement, the one consists of a semicolon, is syntactically valid in Java. Okay, right. So you can just compute the no body. This program finds a midpoint between I and j. It generates the following output. Right. You can find the midpoint between I and j. Okay, here's how the while loop works. Okay, so I think I should create a new folder called iteration statements. Create a new create situation statements. Then I want to create a new file. I can just simply open that one. No body.java. Loops can have no body, that is a single body. While loops, okay. No, it's okay. Loops can have no, that is single is valid. Plus no body. Static void I find the midpoint. I equals j equals 200, right? And then I'll go while I plus plus is less than j minus. System dot out dot println. You have midpoint is no body for this loop. No body for this loop. Midpoint is Java nobody dot Java get 151. Oh, okay. I think this midpoint is in J. Pretty sure. 149, 151. There we go. Right. Then we have, okay. Here's how this while loop works. The value of I is incremented and the value of j is incremented. These values are then compared with one another. If the new value of I is still less than the new value of j, then the loop repeats. If I is equal to or greater than j, the loop stops. Okay. Upon exit from the loop, I will load the value that is midway between the original value and j. Of course, this procedure only works when I is less than j to begin with. Right. As you can see, there is no need for a loop body. All of the action occurs within the conditional expression itself. In professionally written Java code, short loops are frequently coded without bodies when the controlling expression can handle the details itself. Okay. We have a do while. As you just saw, if the conditional expression controlling a while loop is initially false, then the body of the loop will not be execute at all. However, sometimes it is desirable to execute the body of a loop at least once, even if the conditional expression is false to begin with. In other words, there are times when you would like to test the termination expression at the end of the loop rather than at the beginning. Fortunately, Java supplies a loop that just just that, the do while loop. The do while loop always executes its body at least once because its conditional expression is at the bottom of the loop. So you do body then conditional expression. Each iteration of the do while loop first executes the body of the loop and then evaluates a conditional expression. If the expression is true, the loop will repeat, otherwise the loop terminates. Right. Loop terminates. As with all Java loops, condition must be a Boolean expression. Here is a revoked version of the tick program demonstrate do while loop. It generates the same output and do and NN. Okay, the loop within the preceding program, while technically correct, can be written more efficiently as follows: do system node minus minus. Okay. In the following example, the minus minus expression combines the decrement. Right. This is efficiently writing the code. This combines the decrement of n and testing of 0 into one expression. Okay, so basically we did just this. Do start a body, then we just tick and then while we go n minus minus greater than c. Define int n equals 10. Or maybe I can write it in a do while. Right, minus minus. Okay, there we go. So the do while loop minus minus decrementing and returning value of n. This value is then compared with 0. If it is greater than 0, the loop continues, otherwise it terminates. The do while loop is especially useful when you process a menu selection, because you will usually want the body of a menu to loop to execute at least once. Consider the following program, which implements a very simple help. Oh, right. Want it to execute at least once. Right, that's why when I write the loop for I have to call the print again and again. I have to print the call function twice instead. Right. This is great, man. The do while loop. The do while loop is especially useful when you process a menu selection, because you will usually want the body of a menu loop to execute at least once. Consider the following program, which implements selection iteration statements. Right. Here's a simple. Okay. So I think I should write it. Right. Just write the okay, so we have Using a do while to process a menu selection. Then we have class menu and public static void main string. Okay, I want this function to throws java.io.exception args, and then we go throws java.io.io exception. And we have a char choice. And then I want to do first I want to print all the menu, right? System dot print line help on just if switch one dot if then we have switch while do while switch then while then do while and then we have for. And then we print a new additional new line. Okay, then we move on to system.out, choose one. Okay, on to print choose one, and we go system.end, right? Then we take system.end.read. Okay, choice equals casting it to car system.end.read, and then we go while choice is not one, or okay, choice is either one less than choice is either less than 1 or choice is greater than 5, either less than 1 or choice is greater than 5. Okay, while choice is less than 1 the choice is greater than 5. Huh. Is the ASCII, let me take a look at the ASCII table. Less than 1, it should be less than 5 and greater than 1. Okay, then we print a system. Okay, so this choice will, okay, it breaks, right? Because the condition is false here. So we are only breaking the loop. Then we print a new line. The new line, new, and then we put a switch choice. We go case 1, right? Case 1 is if the now I really need hmm, the typing experience on this thing is not that great. Okay, the if we have system if condition statement. Okay, the if okay, condition condition and then statement, and then we have else statement, and then we break. Okay, I'm not writing it, just going to let it go here, but I get that even though the condition is false, the body will still run at least once. So we will Java, choose one, yep, number one as condition, and that is all. Okay, in the program, so I have in the program the do while loop is used to verify that the user has entered a valid choice. If not, then the user is reprompted. Since the menu must be displayed at least once, the do while is the perfect loop to accomplish this. A few other points in this example. Notice that characters are read from the keyboard by calling system.in.read. Okay. This is one of Java's console input functions. Although Java's console I/O won't be discussed until chapter 13, system.read is used here to obtain the user's choice. It reads characters from the standard input returned as integers, which is why the return value was cast to char. Okay, system.in.read. By default, the standard input is line buffered, so you must press enter before any character you type will be sent to your program. Okay. Java's console input can be a bit awkward to work with. Furthermore, still Java programs will use a graphical user interface. For these reasons, not much use of console input has been made in this book. However, it is useful in this context. One other point to consider, because system.in.read is being used, the program must specify the throws java.io exception clause. Okay. This line is necessary to handle input errors. It is part of Java's exception handling features, which are discussed in chapter 10. IO exception. Okay, the for loop. Then you were introduced to a simple form of the for loop in chapter 2. As you will see, it's a powerful and versatile construct. There are two forms of the for loop. First is the traditional form that has been in use since the original version of Java. The second is the newer for each form added by JTK 5. Okay, both types of for loop are discussed here, beginning with the traditional form. Alright. And then you have Hazer form of the traditional for statement for initialization, condition, and then iteration, then body. If one statement is being repeated, there is no need for the curly braces, right? But at the what is thumb of rule of thumb, should always use curly braces. The for loop operates as follows. When the loop first starts, the initialization portion of the loop is executed. Generally, this is an expression that sets the value of the loop control variable, which acts as a counter that controls the loop. It is important to understand that the initialization expression is executed only once. Okay. Next, condition is evaluated. This must be a Boolean expression. It usually tests the loop control variable against a target value. If this expression is true, then the body of the loop is executed. If it is false, the loop terminates. Next, the iteration portion of the loop is executed. This is usually an expression that increments or decrements the loop control variable. The loop then iterates, first evaluating the conditional expression, then executing the body of the loop. Okay. And then executing the iteration expression with each pass. This process repeats until the controlling expression is false. Okay. Declaring loop control variables inside the for loop. Okay. Often the variable that controls the for loop is needed only for the purpose for the loop and is not used elsewhere. When this is the case, it is possible to declare the variable inside the initialization portion of the for. Right. So when you declare a variable inside a for loop, there is one important point to remember. The scope of that variable ends when the for statement does. That is, the scope of the variable is limited to the for loop. Outside the for loop, the variable will cease to exist. If you need to use the loop control variable elsewhere in your program, you will not be able to declare it inside the for loop. Scope is only valid within the for statement. Okay, when the loop control variable will not be needed elsewhere, most Java programmers declare it inside the for. Here's a test for prime numbers. Okay. Then we have declares, for example, here's a simple program that tests for prime numbers. Notice that the loop control variable I is declared inside the for since it is not needed. Find primes. Bigger number equals 14. If number is less than 2, we set prime false, else prime is true. Then we go int I equals 2, I less than num divided by, and we take the, okay, if any of the numbers divide that till if num of I, and it should be less than equals to num divided by, okay, I should be right, we divide it, then we take the remainder. If it is 0, its prime is false. Okay, its prime is not prime. Okay, this is a good one. I should try that. Finding primes like that. Okay. Find prime.java. Okay. Test for primes. Okay, if any number, if I is less than or equal to num by I, if it is okay, if it is not equal to, if I becomes greater, we terminate the loop. Okay, plus find prime. And we have num and boolean is prime and equals 14, and if num is less than 2, equal is prime equals false, else is prime. Okay, so we are putting a starting condition that we assume that it is true, it is a prime, then we will and I equals to, and we will put a condition on I that I am I plus plus, and if any number, right, uh, if the mod is 0, then it definitely divides the loop and we break out. Then finally we print if is prime, then we have is prime, print system.out print line prime, and else not prime. Okay, so we run this. Says is primer not okay, great. Okay, so it will go to num I divided by I, so 7. Okay, so it will always keep up to like 7 and then what else, 3 by 4. Okay, so it will never reach. Okay, right, so yeah, basically going up to half of num and dividing them. This is 2, then this will be 3, 4 and 5, right, 5 at, it won't be 3 and it won't be, okay, so it'll just go till 2 to 3 iterations, right. Okay, this is a nice way to find primes. Okay, but there's also one with square root. We can divide it with the square root, but I think this looks better. Okay, then we have okay, we have found the primes again. So using the comma, there will be times when you want to include more than one statement in the initialization and iterator portion for the for loop. For example, inside of the loops, here a and b, a equals a less than b, okay, b minus minus, a plus plus, b. Okay. As you can see, the loop is controlled by the interaction of two variables. Since the loop is governed by two variables, it would be useful if both could be included in for instead of B being handled manually. Right. So we can use commas in the iteration and initialization portion to initialize and iterate more than one iterating variable. Fortunately, Java provides a way to accomplish this. To allow two or more variables to control a for loop, Java permits you include multiple statements in both the initialization and iteration portion of the for. Each statement is separated by a comma. Okay. Using the comma, the preceding for loop can be more efficiently coded. Okay, right. In this example, the initialization portion sets the value of both a and b. Two comma separated statements in the iteration portion are executed. Each time the loop repeats, the program generates. Yeah. Some for loop variations. The for loop supports a number of variations that increases its power and applicability. The reason it is so flexible is that its three parts: initialization, conditional test, and iterations do not need to be used for only those purposes. Okay. In fact, three sections of for can be used for any purpose as you desire. Okay, this is interesting. One of the most common variation involves the conditional expression. Specifically, this expression does not need to test the loop control variable against some target. In fact, the condition controlling the for can be any Boolean expression. Right. Well, not done if interrupted. Done equals true. Okay, in this example, the for loop continues to run until Boolean variable done is set to true. It does not test the value of I. Okay, here is another interesting for loop variation. Either the initialization or the iteration expression or both may be absent as in the program. Okay. Or where? Okay. Then here the initialization and iteration expression have been moved out of the for, thus parts of the for are empty. While this is of no value in this simple example, indeed it would be considered quite poor style. There can be times when this type of approach makes sense. For example, if the initial condition is set through a complex expression elsewhere in the program, or if the loop control variable changes in a non-sequential manner determined by actions that occur within the body, it may be appropriate to leave these parts of for empty. Here is one more for loop variation. You can intentionally create an infinite loop, a loop that never terminates if you leave all three parts of for empty. Okay. This loop will run forever because there is no condition under which it will terminate. Although there are some programs such as operating system command processors that require an infinite loop. Most infinite loops are really just loops with special termination requirements. Okay. As you will soon see, there is a way to terminate a loop even if an infinite loop like the one shown. That does not make use of normal loop conditional expressions. Okay. Okay, then we have the for each version of the for loop. Okay. A second form of for implements a for each style loop. Okay, the for each version of the for loop. A second form of for implements a for each style. As you may know, contemporary language theory has embraced the for each concept, and it has become a standard feature that programmers have come to expect. A for each style loop is designed to cycle through a collection of objects, such as an array, in strictly sequential fashion, from start to finish. Okay. In Java, the the for each style loop is also referred to as an enhanced for loop. Okay. The general form, the general form of the general form of the for each, the general form of the for each version of the for is shown here. Okay, so type of iteration variable collection statement block. Okay. Here the type specifies the type, and iterator variable specifies the name of the iterator variable that will receive the element from a collection, one at a time from beginning to end. The collection being cycled through is specified by collection. Okay. There are various types of collections that can be used with for, but the only type used in chapter is the array. Other types of collection that can be used with for, such as those defined by the collections framework, are discussed later in this book. With each iteration with each iteration of the loop, the next element in the collection is retrieved and stored in iteration variable. The loop repeats until all the elements in the collection have been obtained. Because the iteration variable receives values from the collection, type must be same as the compatible with the element stored in the collection. When iterating over array, type must be compatible with the element type of array. Okay. To understand the motivation behind a for each loop style, consider the following for loop, and it is designed to replace. The following fragment uses a traditional for loop to compute the sum of the values in an array. Okay, so we have sum equals sum. To compute the sum, each element in nums is read in order from start to finish. Thus, the entire array is read in strictly sequential order. This is accomplished by manually indexing the numbers array I and the loop control variable. For each loop, okay. The for each style for automates the preceding loop. Specifically, it eliminates the need to establish a loop counter, specify a starting and ending value, and manually indexing the array. Instead, it automatically cycles through the entire array, obtaining the elements at a time in sequence from beginning to end. For example, here is the preceding fragment written using for each. Right. With each pass through the loop, x is automatically given the value equal to the next element in nums. Thus, on the first iteration, x contains 1, on the second iteration, x contains 2, and so on. Not only is the syntax streamlined, but it also prevents boundary errors. Here is an entire program that demonstrates the for each version of the for just described. Look at the output here. As this output shows, the for each style for automatically cycles through an array in sequence from lowest to highest index. Although for each loop iterates until all elements in an array have been examined, it is possible to terminate the loop early using a break statement. Okay, for example, this program sums only the first 5 elements of the num. Right. System. Okay, so value output is 20. As is evident, the for loop stops after the 5th element has been obtained. The break statement can also be used with Java's other loops and is discussed Uh, as is evident, the for loop stops after the fifth element has been obtained. Okay. The break statement can also be used with Java's other loops, and it is discussed in detail later in this chapter. There is one important point to understand about for each style loop. Its iteration variable is read only as it relates to the underlying array. An assignment to the iteration variable has no effect on the underlying array. Okay, this is important. Read only. Variable has no effect on the underlying array. In other words, you can't change the contents of the array by assigning the iteration variable a new value. Okay, no effect. The first for loop increases the value of iteration variable by a factor of 10. However, the assignment has no effect on the underlying array nums. So on. Okay, so let's code it up. Okay, so Java demonstrates the for each loop. So I have, then we start with an int array nums, right? 1 2 3 4 5 6 7 8 9 10. Okay, and then we declare int sum equals 0. Then for int x and nums, we go, first we'll define current number, out dot println current num x, and then we supply the sum x, and then we Java queries.java. Okay, there you go. So let's call it a day today.